In this video, I will show you how you can set up linting in your IDE so that you can have all the benefits of having a linter in your Python project. For example, catching bugs early and identifying code smells and code issues. And after we've set up the linter, I will show you how the linter will help us catch issues before they become issues. So as usual, I will show you what life is like before linting, and I will show you how you can enable it in your IDE. We install a dependency. In this example, we use pylint, but there are others out there that you can also use. And then we'll tell our IDE to use this linter. And next, we will improve a problematic piece of code by following the rules. And I'll show you how you can run pylint as a bash command so that on a CI server, before you run your unit tests, pylint can run and fail the build and give you fast feedback to tell you that there are some problems in our code. And lastly, I'll show you how you can configure pylint itself. If you are coding along with this video, you should first watch my first video on configuring your IDE and then come back to this. So life before linting. This is a problematic piece of code and it's not always obvious what the issues are. Let's run this code and see what happens. So it turns out that we actually had some actual errors. There's this variable entry and it's not defined anywhere. And there's nothing to tell us while we're writing this that there's a problem. So until we run it, we will have a runtime exception and our users are the ones probably seeing this issue and our application will fail. And there are some other issues as well, such as unused variables, date code, which generally makes the code hard to read, and non-Pythonic ways of defining variables. So let's install a linter and see how the linter will help us identify these issues before they become bigger issues. First, we'll install the dependency. So let's go to requirements text and we'll add pylint. Let's install the dependencies. I've already activated my virtual environment. And once we've done that, we can now tell our IDE to use that linter. And to do that, we'll open our command palette by pressing F1. And we'll say select linter. And now, there are a few that we can use, but we've only installed pylint, so that's the one we will select. And now let's look at our code. Immediately, the editors helpfully told us some issues. We have an undefined variable, and we have unused variables. So let's fix these issues one by one. And now we can run our code, and everything is okay. Now let's add back some of the issues that the linter found, and I'll show you how you can detect them on CI. Let's say now we have this code smell and it's an unused variable and we have written our code, happily checked it in and went for lunch. And how can we catch this issue and prevent such issues from polluting our code base? So once we've installed pylint, and we can lint all of our source code by running pylint. You can also give it a path to the directory, but in this example I just want to show you the issue for one file. And you will see that the exit code is non-zero, and any command run on CI where it has a non-zero exit code will fail the build and tell you that there's some issues with the code. There are a bunch of issues which VS Code is hiding right now, which I will cover in the next minute or so. But for now, once you have fixed the issue, if there are no further issues, you would be able to run this code and the exit code will be 0. But now let's understand why VS Code is not showing us all of the issues that pylint is discovering. And in preparing this tutorial, I discovered that VS Code has some default settings for pylint, which is different from what pylint actually checks for. So let's change that VS Code setting so that we get exactly what pylint offers. So let's open our command palette and look for our settings. In this case, I'll choose the UI. And inside here, you can search for pylint, and there will be some pylint configuration options. All the way here, at the end here, there is one option, pylint use minimal checker, whether to run pylint with minimal set rules or not. So let's experience pylint in its entirety, and we'll see that it discovers even more issues. For example, the function name here does not conform to the snake case convention. N1 and N2 are abbreviations, and that should be avoided. There's missing methods in docstrings. In the remainder of this video, I will use this as an example to show you how you can further configure pylint for the needs of your project. The goal is to either fix these warnings one by one, or to ignore them if it's not relevant to our project, and run pylint again and see that it returns a zero code if there are no code issues in our code base. So the first issue is that we have a missing module docstring. And let's say in this project we don't do docstrings. We can tell pylint to ignore this. So what we can do is to leave a comment and say pylint disable. And what you're going to pass in next is the rule here, which is here, missing module docstring. And now that should go away. I guess I have to put it at the module level. And now that's gone away. The next warning is valid, so I will want to fix this and make add two numbers conform to snake case. So I'm going to rename this. I press F2, change it to add two numbers. And now that's gone away, and we can quickly fix some of these issues as well. N1 and N2 has an invalid name. So let's say I don't want abbreviations here. And finally, a missing function docstring. So we can also edit here. There's a trailing white space here, so we can fix it. And if you're thinking that this actually makes the code harder to read because I have comments everywhere, you're probably right. All of these can actually go into a global pylint RC configuration file, so that these rules are applied globally, so that if you have 10 functions, you don't even need to add these comments to any of them. These rules in that RC file will apply globally. So let's go ahead and create a pylint RC file. So here we have two options. We can either generate an RC file, or we can create one ourselves. Generally, I prefer to create one myself, but I'll show you both ways so you can pick what works for you. So the command to do that is pylint generate RC file, which will just output a bunch of text, and we will put this text into a file. So now we have a new pylint RC file, which has kind of a template. And to me, this is a little bit overwhelming, especially if I'm starting out first. So another option is to create this file yourself and only put in what you need, rather than have a big chunk of things that are just there magically. So we can create a file like how we just usually create a file. We call it pylint RC. And here the header for ignoring warning messages is messages control. And we just say disable, which takes in a list of the rules that you want to disable. And that would be these two in our case. And when that's done, we can remove these. And the linter would still be happy with that, because now our pylint RC is saying ignore these things. For example, if I was to remove this, now the warning will come back saying that this is a problem again. All right, so let's run our linter again. And we see that now our code is free of issues. And when you've set this up for your project, you can ensure that code quality is being monitored and conformed to on a continuous basis, so that you don't collect large chunks of code that are problematic and hard to maintain. And by the time we've realized that, maybe it's too late. So having a linter is something that I would absolutely do early on in the project as a kind of default configuration in a project, so that as I collaborate with other people, or even as I write code myself, I make sure that the code is continuously in a healthy state. Okay, so we've learned how to enable linting in our IDE. We've learned how to improve our code by fixing the linter rules. We've run pylint as a bash command, and we've learned how to configure a pylint either using inline commands or using a pylint RC file.